Hello my super students, how are you today? I hope you're fine. Today we are going to study operations on natural numbers, but before we start we have to remember that the natural numbers is denoted by n, or the set of natural numbers is denoted by n equals 0, 1, 2, 3 and so on. So the set of natural numbers is an infinite set. In the set we have a start point and no end point, and we have studied how to represent the set on the numbers line, So we have to use this ray. We draw this line segment, then we have a start point as 0 and no end point, so we use this arrow. So we have a start point and no end point. We have 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on. So now we represent the set of natural numbers on the number line, or this ray will help us to represent the set of natural numbers. Today we are going to study operations on natural numbers. The first operation is how to add two natural numbers using this number line. For example, if we have 5 plus 2 equals, okay, if we need to use this ray to solve, or this number line to solve this question, we have 5 plus 2. So we start from 0, then we have 5. So we move to 5. 1, 2, 3, 4, 5. Now we are in 5. So we move from 0 to 5. Okay. Now we need to add 2. We need to make the addition by adding 2 to 5. So we have to say 5 plus 2, so 1, 2, so 5 plus 2 equals 7. 5 plus 2 equals 7. And by another way, if we say that we can use the commutative property of addition, that we say 2 plus 5. If we need to add 2 plus 5, so we start from 0, then we go to 2, so 2, then we add 5, so we have 1, 2, 3, 4, 5, so 2 plus 5 also equal 7. So 5 plus 2 is equal to plus 5, and we had studied that's called the commutative property of addition. And notice that if we add any two natural numbers like 5 and 2, the sum will be a natural number. So 7 belongs to the natural numbers. And in this example, we have 2 plus 5. 2 is a natural number and 5 is a natural number, and the sum belongs to the natural numbers. So this property called closure. So the set of natural numbers is closure and adding. Why? Because if we add any two natural numbers, the sum will be a natural number. And the third property is called associative property. So let's learn what is the meaning of associative property or associated property. The meaning of associative property is if we have any three numbers, A and B and C, A plus B all plus C, so A plus B all plus C equals B plus C all plus A. So what is the meaning of that? This is mean if we have A equals 2 and B equals 1 and C equals 3. So now we need to add these three numbers. So we have to say if we have A equals 2, so 2 plus B equals 1, so 2 plus 1 plus 3 is equal B equals 1 plus 3 all plus 2. So if we make the addition with 1 and 2, then we add 3, that will be the same if we add 1 plus 3, then we add 2. So 2 plus 1 equals 3 plus 3 equals 1 plus 3 equals 4 plus 2. So 3 plus 3 equals 6 and 2 plus 4 equals 6. So this is the same. And this is the associative property of addition in natural numbers. And the last property is called the neutral additive. The neutral additive. Okay, what is the meaning of the neutral additive? The neutral additive is called 0. Why? Because any number, for example, a plus 0 equals 0 plus a equals 0. Because if we add 0 to any number, the sum will be the same number. The sum will be the same number. For example, 2 plus 0 equals 2 and 3 plus 0 equals 3 and any number plus 0 equals the same number. So 0 is called the neutral additive. So these are the addition properties in natural numbers. We have 4 properties. The first one is called closure, and the meaning of closure is if we add any two natural numbers, the sum will be a natural number. And the second property is called the commutative property. In commutative property, if we have 2 plus 3, that will be equal 3 plus 2. So 2 plus 3 equals 3 plus 2. And the third property is called the associative property. And in associative property, if we have any 3 numbers like a, b, c, if we say a plus b all plus c, that will be equal b plus c all plus c. And the fourth property is the neutral additive, and the neutral additive is 0. The neutral additive is 0. And now let's learn how to use this numbers line to subtract. Okay, for example, if we have 9 minus 7, 9 minus 7, so we have to say 9 minus 7, we start from 9, so we go to 9, then we have to move back or move to the left for 7 steps. So we have 1, 2, 3, 4, 5, 6, 7, so 9 minus 7 equals 2. So 9 minus 7 equals 2. And if we have 7 minus 9, 7 minus 9, that will be equal. Okay, so we have to go to 7, then we count back for 9 steps. So we have 7, then we have 1, 2, 3, 4, 5, 6, 7. Okay, what can we do? We can't find the difference between 7 minus 9, or we can't solve this example in natural numbers. So sometimes the subtraction is not possible in n. So not possible in n. So sometimes the subtraction is not possible in n. And now let's solve some exercises. In our book we have this practice. Complete to get a true sentence. And letter A, we have 213 plus 57 equals 57 plus what? So here in letter A, we have to use the commutative property. The commutative property. We have to use the commutative property because 213 plus 57 equals 57 plus 213. And in letter B, 28 plus 72 plus 59 equals 28 plus what? Plus 59. So we have to write 72. So we have 72. So 72 plus 28 equals 100. So the associative property help us to find 100 or to make the addition more easier. So we have 100 plus 59 equals 159. So we use the associative property. And in letter C, we have 0 plus 4,365 and 0 called the neutral additive. The neutral additive. So the neutral additive plus any number equals the same number. So we have 4,365 and this property is called the neutral additive. The neutral additive. So let's look at the second question or at letter D. And letter D, we have 999 plus 487 plus 1. Okay, so that's equal 999 plus what? Plus 1. So we have to say 487. 487 plus 1. And this property is called the associative property or associated property. And here we have 999 plus 1 plus 487, and we use the commutative property. Then we have 1 plus 999, so this is the associative property. We have here 487, and 1 plus 999 equals 1000 plus 487, so we have 1487. I think this is clear to you. So let's try to look at the practices and the subtraction, but we have to notice that subtract if possible. In letter A we have 5 minus 3, and in letter B 3 minus 5. Calculate 5 minus 3, we go to 5, then we move back or we move to the left for 3 steps, so we have 2, and this is possible. And in this figure or in this number line we have 3 minus 5, so we go to 3, then we have to move to the left 5 steps, and we have just 1, 2, 3 steps, so this is not possible. This is not possible. So the subtraction operation is sometimes not possible in n. For any two natural numbers a and b, then a minus b is possible only if a is greater than or equal b. A is greater than or equal b. And now let's solve this practice. Complete using belongs or doesn't belong. In letter A, 3 plus 7. 3 plus 7 equals 10, and 10 belongs to the natural numbers. And in letter B, we have 45 minus 35. We say for any two natural numbers a and b, the first term in subtraction should be more than or equal the second term. So we have 45 is greater than 35, and the difference between these two numbers equals 10, so this is belongs to n. And in letter C we have 8 minus 10, and we had started that if we have a minus b, so a should be more than or equal b, so this is doesn't belong to the natural numbers. And in letter D we have 28,727 minus 9,543. For any two numbers a and b, a should be more than or equal b, and now a is more than b because 28,727 is more than 9,543, so this is belongs to n. Now we finished the first part of our lesson, and we will complete the second part in the next session. Good luck.